In this video, I'm going to show you how you can change the order of integration to evaluate a triple integral. So here you've got dy, dx, dz. You can switch these around accordingly. So looking at this, you do not want to integrate this with respect to y first, because you've got y squared here and then you've got e here. It's like me asking you to integrate this, which is with respect to y, which is a nightmare to integrate. So rather than integrating with respect to y first, let's have a glance at this. Do we want to integrate it with respect to z first or with respect to x? So looking at this, if you look at z exists here and exists here. And then if you look at x just exists here. So here we want to integrate it with respect to x first, because it's a lot easier than with respect to z. Because when you integrate it with respect to x first, you can treat this whole thing here as being a constant, and this is just a constant. Here, if you're integrating with respect to x, then x is your only variable here. So we want to integrate it with respect to x first. Now the next question is, do we want to integrate it with respect to y and then dz, or dz and then dy? Well, we haven't decided yet on this bit, so let's just do it with respect to x first, and then later on we can decide on the latter two. Okay, so before we can change the order around, we need to understand the region in which we're integrating over. So draw your diagram. So this is x, y, and z. So if you look at the inner integral, this thing here would be y. So that would be y equals something. Y equals something. If you look at this bit here, y equals x squared. Y equals x squared looks like this. But then on the 3D diagram, it will look like this. It will look like this. And so looking at the y, you're integrating with respect to y first, meaning you're moving parallel to the y-axis, and you're doing it from the quadratic to 1. So you're doing it from the quadratic to 1. You're doing it from the quadratic to 1. So let's just say 1 is here. Well, if this is 1, because of y equals x squared, this must also be 1. So we know that this is also 1. So looking at this, you're integrating from x squared to 1, integrating from x squared to 1. You're integrating from x squared to 1. You're integrating from x squared to 1. So it looks like you're looking at this region here. You're looking at this region here. It looks like that. So now in terms of the x now, if you're integrating from x from 0 to 1, so you can see you're integrating from 0 to 1. And then in the z direction, you're doing it from 0. Remember, z means you move parallel to the z direction. You move parallel to the z axis. So that means you're going to have a height of from 0 to 1. So that means you're going to have a height of 1. So hang on, let's just say this has a height of 1. So what that means is this has a height of 1. So hang on, and then a height of 1. So this here would be, hang on, so it will look something like this. It will look something like this. So hang on. So the region in which you're integrating over looks like this. I hope you can visualize this. Well, the region in which you're integrating over looks like this. Okay, so it has a height of 1, and then you've got a 1 here, and then you've got your quadratic here. This is y equals x squared, and then you've got your quadratic here with a height of 1. I hope you can see that, you can visualize that. So the region in which we're integrating over is this block here, this 3D block. But the thing is, we want to change this. We don't want to work in terms of y, so we want to work in terms of dx first. So it would be something of this form, x, z, e, z, y squared. We haven't decided on this yet, so let's just leave it as, I don't know, let's just dy. Later on we can switch these two around if we need to. So triple integral, triple integral, triple integral. The inner integral would mean, well, we've got dx here, so that would mean dx equals something, dx equals something. So if we're integrating with respect to x first, it means we are moving parallel to the x-axis. So moving parallel to the x-axis means we are integrating from x equals 0 to the quadratic, x equals 0 to the quadratic, x equals 0 to the quadratic. The quadratic is this thing here, but we want it in terms of x equals something. So rearrange this. So root y equals x. So we're integrating from x equals 0 to root y. Okay, so far we are currently at this stage here. So far we are currently at this stage here. We haven't decided on dz dy or dy dz. We can switch these two around later on when we glance at this later. And remember, we're doing it from 0 to root y. So now integrate this with respect to x, which is nice and easy because this whole block here is a constant. So when you integrate it, it will be x squared with a 6 rather than a 12 from 0 to root y. So now put this into here. So that will then just be y. And then when you put 0 into here, the whole thing disappears. So after this step, that will then take us to here. And then now we've got to glance at this and decide, do we want to integrate this with respect to z first or with respect to y first? So let's look at z first. You've got a variable here, a variable here. So it's like me asking you to integrate something like this. Which is easier? E to the power of, let's say, this thing here, dx here. Or if you do it with respect to y first, then this is a variable. This would be a variable. So it would be this. Hang on. Which would be easier? X and then e x squared dx. So hang on, let me clean this up. So the question is, do we want to integrate it with respect to z first and then y, or y first and then z? You see, if you do it with respect to z first, it will be like me asking you to integrate this. If you do it with respect to y first, it's like me asking you to integrate something like this. You see, this is easier to integrate because this is near enough the derivative of this, so you know it's going to be easy to integrate. Glancing at this, you can tell that this is easier to integrate than this, because this thing here is a derivative of this x squared. Here, take my word for it, this thing here is a lot more difficult to integrate than this. So we want to because the y here is the derivative of y squared, we want to integrate it with respect to y first. So we want to integrate it with respect to y first, and then with respect to z. So that means we've got to switch this around. Well, these two will have to be switched around. So it will be y equals something, y equals something. So y, if we're doing it with respect to y first, it means we're moving parallel to the y axis. So hang on, let me think. X. Yeah. So if we're moving from in the y direction, it would mean that we are integrating from. remember earlier we integrated with respect to x first. So so our 3D solid will lose one dimension. It will lose the dimension x. So this whole solid will get flattened. Will get flattened to a 3D sheet, looking like this. So this solid, remember, once you've integrated with respect to x, you lose one dimension in the x direction. So this 3D solid will get flattened. Will get flattened to this region here. Hang on, to this rectangle here. To this rectangle here. And then if you're going to integrate it with respect to y, it means you're moving in the y direction like this. You're moving the y direction, and you can see that you're integrating from y equals 0 to 1. Y equals 0 to 1. And then once you've integrated with respect to y, then your rectangular sheet here will collapse down into, well, it's going to lose one dimension in the y direction. So sorry, it's going to lose one dimension in the y direction. So that means this sheet of paper will get collapsed down to here. So it will look like this. So it will look like this. And you're integrating it from 0 to 1. Okay, sorry, my mind went blank then. So from 0, hang on. So this thing here was from 0 to 1. So that's this sheet of paper here. Once you've integrated with respect to y, this sheet of paper will collapse down. So you're looking at this line here, the line here from 0 to 1. So z will be from 0 to 1. Sorry about that, my mind went blank. So that will then take us to here, and then we've got to integrate this with respect to y. So integrating this with respect to y, because we know this is the derivative of this, let's just, instead of using substitution, let's just integrate it. Let's just guess the integration, because we know this is going to be easy to integrate. So I'm going to look for something in such a way that when I differentiate it, it will give me this thing here. So so let me make this guess. By the way, you could use you could use substitution, but we're just going to guess our way to the answer. So now, if I were to differentiate this with respect to y, this thing here with respect to y, so so it would be 3ez y squared times the derivative of this bubble itself, which will be 2zy, and then you can see you've got your 6 here, and then you've got your zy here, which is this thing here, and then you've got your ezy squared here. So the point here is that to integrate this, it then becomes this. Use substitution if you want, but train yourself to just guess your way to the answer. It's much quicker. Well, anyway, from 0 to 1, from 0 to 1. So now we can put 1 into the y, so that will then give us this, and then put 0 into here. So this whole block here will be the number 1. 1 times 3 is 3, and then integrate it with respect to z. So integrate this with respect to z. Integrate it with respect to z from 0 to 1, and put 1 into here. That will then give you this. Take away, put 1 into here. That will then give you this. And then when you put 0 into here, it will become 3 here, and so on. So that will then take you to here. The final answer is this. Okay.